My name is Sameer Vasan. I manage TI's processor business. And first of all, I wanted to thank all of you for spending the afternoon with us. Hopefully, we'll be able to share some updates on our products and be happy to answer any questions towards the end of it as well. So let me start. The way this will go is I manage TI's processor business. So in our processor business, we focus on multiple markets, including automotive and industrial, and multiple product lines. Today, specifically, we want to talk to you about the automotive side. But before we do that, I want to spend just 5-10 minutes giving you an overview on what are we trying to go do and what are we investing in. So let me start by first saying, as you're well aware, semiconductors is a rapidly evolving field. We are becoming a more central portion of systems every day. As these systems become more and more complicated, what our customers expect from us in terms of helping them solve the problem, that is becoming more central. And this is something which we at TI are actually very excited about, and that is what we spend a lot of time on. So if you look at the key trends, whether it is advanced integration, higher performance, data processing, versatile solutions, focus on software, these form the basic vectors or the basic tenets of how we go around doing R&D. These are evolving, these are ever present for us, for many people in this industry. So let me take 3 examples of end equipments or products which we see almost on a daily basis nowadays, and how these 3 examples give you an idea of how our industry is evolving. So if you look at a thermostat is on the wall there. We've all had thermostats for years. These thermostats have been simple. They used to control temperature, tell you the time sometimes, and that's it. Today, these thermostats are evolving to be smarter. These thermostats have a lot more technology in them. They can do a lot more than just tell you temperature or control temperature. Some of them are getting into smart homes. That real estate around a thermostat is something which is getting used and monetized multiple times over. So that requires us to still stay in that constrained environment of power, cost, form factor, but bring in a lot more technology in that simple thermostat. Next example here is industrial robot. Something which we've seen around for about 5-7 years now. And it is probably in the mid-size or mid-scale of its evolution. That being said, our industrial robots today still don't interact with humans as seamlessly as we would like them to. This technology is still evolving. From a safety perspective, as these cobots or these industrial robots become more safe, the interaction with humans, the coexistence with humans improves. So our technology across the portfolio is looking to make that interaction more seamless. The third example I have here is something which everyone's aware of, EV, HEV. This is relatively nascent in its adoption. How our technology in semiconductors is going to help EV, HEV adoption at a mass scale, whether it is from a safety of battery, whether it is extending range, whether it is getting more analytical capability in the automobile, that's where our technology is evolving and we are helping. So 3 simple examples of products which we see, which we use in our daily life, and how semiconductor technology is helping move them so much more forward, one step at a time. So let's take the next step. So now the same 3 examples, right? So something inside your home, something inside a factory, or something on the road as an automobile. Where is my business investing most of our time? Where are we trying to go innovate and move that forward? So what we focus on across the business is automation, connectivity, and control. The combination of these 3 help machines get smarter, help these end equipments become more mass adopted and more intelligent than they are today. When I say automation, I mean analytics, deep learning, machine learning. A good example is what Kurt is going to come up and talk about from an automobile perspective. When I say connectivity, this is both wired and wireless connectivity. And when I say control, this is real-time control with safety, and how are we bringing these together to help move such end equipments forward. Next, opportunities and impact at the edge. I like to highlight that very specifically because our business is a business of low power, low cost, embedded at the edge. You can solve these problems in the cloud, you can solve these problems with general purpose compute, but what we specialize in is solving these problems with a very clear understanding of the system and interpreting that in the lowest power and the lowest cost, because that is what enables the widest adoption of our technology. Last, integrating new capabilities and understanding the system. That goes to the core of what we want to do. Our engineers spend a lot of time understanding customer problems, understanding customer systems, and then interpreting that as solutions through semiconductors. So we express ourselves through semiconductors by understanding those problems, and understanding those systems is at the very core of it. Hopefully today, you will see a very good example of how we have understood the automotive market, especially in ADAS and gateway, how we have taken time to go develop technology and express how we're going to go solve some of the very significant challenges we have there, and we're excited about what we're bringing to you. With this, I'm going to hand it over to Kurt.
Good afternoon, and thanks everybody for being here. My name's Kurt Moore, and I manage the Jacinto processor family. Just to give you a little bit of background, TI has been in the automotive industry for over 30 years. We've really been in the functional safety business for about 25 years. We've been in the automotive processing business for almost 20 years. So we have a long history, and the Jacinto family is a very large, successful family within Texas Instruments. And what I'm excited to talk to you all today about, is the Jacinto 7 family, which we introduced last week at Las Vegas at CES, with products that are shipping to customers, or shipping with customers developing products on it today. And I want to explain to you what it's all about and where we're going with this family. So let's start about why did we develop the Jacinto 7 family? The first thing is the automotive industry has a large challenge, right? Today, according to the World Health Organization, there's 1.35 million people a year that are killed on the roads. So there's a huge problem and huge opportunity for us to help improve safety on the roads. The second thing we've learned, though, is that ADAS really works. Cars that have things like automatic emergency braking are in 50% fewer accidents. However, the reality is most of that functionality is in higher-end vehicles. And there's lots of ways to make that technology better to further reduce accidents. So there's some great opportunity there. And the final thing is this is really hard. You know, car architecture, electronics architecture has evolved over time, but fundamentally it's based around the CAN network. The CAN network is a relatively low-speed network. And if you look at the amount of software in cars and the amount of data in cars, it's exploding. Back in 2010, there were about 10 million lines of code per cars. In 2016, that had already exploded to 150 million lines per code. All that code is creating a huge maintenance challenge, creates quality challenges, is very difficult to maintain, and is a huge development cost. So what are we introducing? We are introducing and actually are sampling our first two devices in the Jacinto 7 family. The first device is the TDA4 VM, and it's really all about how you can improve sensing in the car. The second device that we're sampling is the DRA829V. Once you get ADAS in the car, there's a massive explosion in the amount of data. And you would really like the data to be used by different domains within the car. Let's give an example, right? If the car senses something, you may want the powertrain to act on it, you may want to display it in the cockpit system, and you certainly want the ADAS system to act on it. That's a huge amount of data going across cars. And what we're really trying, and the other challenge with that is we're really looking at ways of helping cars get updated and with over-the-air type things. So what we're really enabling with this is really the software-defined vehicle by providing that really good way to communicate with a lot of high-speed data throughout the car. And finally, all this is linked together with one software SDK, really addressing the challenge, helping address the challenge our customers have with software development and allowing them to reuse a lot of the same software between all these different applications. It's no secret, though, that the automotive processing market is a very attractive market to a lot of semiconductor suppliers. But TI is doing really three things that, when you combine, make us very unique and offer a very compelling solution. The first thing is the Jacinto 7 product family is really developed to support the needs of the entire vehicle lineup. What does that mean? That means we want to offer optimized SoCs to that in-cap to really L2 plus type range where there's going to be high volumes and systems need to be really cost optimized. But we also want to let customers reuse that same software into the higher levels of autonomy vehicles and really support the entire product line or their entire product line. We want to have this technology into all vehicles. The second thing is this is designed for automotive. And what do I mean by that? If you really look at where automotive processors are going, they're moving to the mission critical domain. Very similar to how brakes have always been there, something that's always got to work. So that means you've really got to design in a lot of reliability and a whole lot of safety. And that's not something you can add to a device. And when we really started the Jacinto 7 family, we built it with safety in mind from the grounds up, from the IP, from the architecture, and how we're approaching the entire technology. And finally, we really architected this with analytics in mind, recognizing the huge amounts of analytics that are going to be required to really make cars safer. So let's get practical on what does this really mean on one of the first devices we've introduced, which is the TDA4V mid. The first thing we did is we put in multi-level processing. Why did we do that? Because you need determinism and you need reliability. So first thing we did is we put two types of analytics on this SoC. The first is traditional computer vision, very deterministic and very important. And we did this through a set of accelerators. The second thing we did, though, at the same time, is put in some great, very efficient deep learning so our customers can use both the computer vision and deep learning to have a very reliable system. The second thing we recognized, though, was to have really large deployment of these ADAS systems. It's got to be done in a very power conscientious manner with a very tight power envelope. So we've really used accelerators to really give the best possible performance for power to hit really SoCs in that 5 to 20 watt range, which do not require any exotic cooling. And finally, we recognize that really the automotive industry is probably the most cost conscious or cost disciplined industry around. And we recognize that really it's going to be all about how do you enable the right system cost. So we had a lot of very smart integration with things like integrating safety, integrating Ethernet switch, integrating the right I/O to really be able to reduce the total system BOM to enable car OEs to really hit the price points they require. So let's get real practical on what does this mean to the driver. One thing fundamental to have a safer vehicle is having a car be able to sense better. And what does that really mean? It means to be able to see farther at higher speeds in bad weather conditions. So what do we go off and do? The first thing we did is we integrated the right analytics for both deep learning, the right amount of memory, and the right amount of computer vision to really provide a good enough analytics to have a good driving experience. The second thing, though, we did is, or another thing you want to have a better driving experience is have a wider field of view, let the car see a wider distance, and also to be able to see further. So what we did is we enabled and really optimized this for an 8 megapixel camera. This expands the field of view so you can see pedestrians on the side of the road or see vehicles crossing over to you, and also be able to see further distances like 200 meters out. And finally, we have an open programmable platform. What does that mean? That means our customers and our partners can innovate on our platform. Let me give you a great example, and it's actually on YouTube along with the rest of the demos that we showed last week at CES. But we're working with a partner called Momenta. They enabled an 8 megapixel camera. The field of view, the wide field of view, the distance is incredible. And allowing them to go innovate on the perception stack is giving new ways to go solve these perception problems. Another example would be Park Assist. And TI largely enabled the Park Assist market, or surround view market over the last several years with the J6 family. And we've recognized with what's really needed for the next generation of more automated park is you fundamentally want to be able to park faster with more assistance from your car, getting closer to the curb in tighter parking places. So what we've gone off and done is we've enabled all the sensing you need with 6 3 megapixel cameras with the right analytics, ability to go integrate things like ultrasonic or radar to really have a much better parking experience. And again, another demonstration you can see on our YouTube videos. But finally, this is not really useful if you cannot hit the right cost points. And when you go look at what's required in these systems, right, it requires great signal processing, really efficient analytics, able to get different levels of safety, and finally, high bandwidth communications. So what have we done? We've really taken the general compute performance required, but reduced that some because we've added a lot of accelerators. Accelerators like, our vision accelerators, our motion accelerators, our image accelerators, our deep learning. We've integrated the Pci Switch. We've integrated the Ethernet switch. We've taken our ASIL-D safety island, so you can integrate that safety island approach. And finally, ways to go render the output. This is really driving a much simpler system, a much smaller footprint system, but also a much lower cost total system. So let's switch and move over to more of the gateway environment. If you look at the car electric infrastructure or architecture today, it's really fundamentally built around the CAN backplane. The challenges with that, though, is it's really difficult for the different car modules to communicate any sort of significant amount of data between them. It also makes it very difficult for any sort of updates without taking your car into the shop. And it's a huge challenge to maintain all the software. So what we did is what we're off doing is helping enable the compute cluster software-defined car of the future. The first thing we did is we integrated the Pci Switch. So why is that useful? Let's say you want a higher level of ADAS, an L3 and L4 type system, where you may have multiple SoCs working on the same data. Well, the Pci Switch is a great way to move data very quickly with the hard real-time requirements between those different SoCs. The second thing is when you start thinking about some of these systems, you're going to have things that are mission critical that could be controlling things like acceleration or braking, and things that are more convenience oriented on the same SoC. What we did is we separated those mission critical functions and those more application functions so they can run concurrently but give that robustness to those mission critical functions. And finally, you're going to want to share data between things like your ADAS systems, your powertrain systems, your cockpit systems. So we've gone off and integrated an 8-port gigabit Ethernet switch to be able to share data between the different places in the car. But again, all this cost matters. You have many of the different functionalities, but the same idea, you've got to somehow go off and hit the same system ball. So what we did is we've really integrated and created a gateway on a single SoC. We've taken the general compute, the real-time compute, the PCIe switch, the Ethernet switch, and the high security module with hardware accelerators for security, all into one SoC, so you really have a gateway on a chip. And it has been incredibly exciting watching what customers and our partners have been doing on the Jacinto 7 family over the last few months. You can see many of those things on YouTube with demos that we showed at CES that we will share with you how to get there. We are sampling these devices now on TI.com, and we have many customers developing great applications and partners developing great software. What we really want this family to be all about, though, is how do you improve awareness of the cars surrounding so that we have safer roads. We want to enable this to go to every car, so again, we can have that better driving experience, that safer driving experience for all drivers. And finally, we want to accelerate the data highway so we have higher quality cars that are easier to maintain. So that's what we're trying to go do. Thank you for coming, and we'll be glad to open it up for any questions.